So hello everyone, and welcome to this webinar, and thank you for joining us today. Today in this session, we will have our own and only lead developer, Chris Gardner, talking about Unreal Engine workflows with Assembler and Visual Assist. As you might know, Visual Assist is a great plugin for Visual Studio to boost your productivity, especially in C++, but also in C#. If you work with Unreal Engine, this is a very good plugin as it will perform extremely well even if the code base gets very large. Not only for some of the Unreal workflows, and we have special features just for Unreal, but for all kind of things, especially around navigations. Either if you want to find symbol, find references, or just jump in between files, Visual Assist will work great in all of your code base very fast. And without any further ado, Chris Gardner, please take the floor. And of course, don't forget to ask questions. As this session gets interactive, it will be much more fun for us and for you too. So thank you again for joining us. And Chris, please take the floor.
All right, Nuno, thank you for the intro. And like Nuno said, just ask questions. And also, if you see any questions that might be, just feel free to just interrupt. Just think of it as like, like a lecture, right? Because it's really a lot more fun, and you can kind of change the direction of what we're talking about. Because I don't have a ton to say. We're not going to spend the whole hour doing this. So let's get started. So session 3, we're trying to break free from IntelliSense hell. That's a bit of, maybe a bit of we had a bit of fun with that. And pro level UE5 C++ development geeks, really, we're going to talk about why Blueprint, why C++. What's the difference? Why would you use one over the other? I feel like I've got a hot take there, so it might be interesting. You might disagree, but that's part of the fun of it, right? So, I mean, if you're an experienced Unreal Engine developer, I think I think you might get a kick out of that. All right. So obviously Unreal Engine 5, geez, does this need an introduction, right? Latest version of Epic's game engine. You can write logic in both C++ and Blueprint. You can see it here. It's this whole mess of things. It's really a whole integrated kit. I mean, what is an engine, right? It's a series of tools. Everyone thinks, oh, writing an engine is easy. I remember I was looking at Twitter, and Notch was like, well, you're not a real game developer unless you write your own engine. But of course, that's crazy because he wrote a renderer and he had all of his content randomly generated. He never wrote a game engine. He never wrote a level editor, things like that. These are what makes a game engine, right? And of course you can interface it with C++ and Blueprint. Before they had Unreal Script, and maybe in the future we'll have that back again. We'll see. So if you've never seen blueprints, you're probably in a small category of Unreal Engine developers, but they're handy. I mean, the concepts like this have been tried before, and it's kind of a way to simplify things. It's kind of easy for you to kind of understand this small amount of logic here. It's a little bit more pleasant on the eye than like C++ code. So I think that's a big part of the reason blueprints exist at all. But there's of course other reasons as well. So we'll get into that a little bit. But of course, C++ is super handy too. And in fact, of course, almost all of the engine, I mean, the engine is C++. Everything is written in C++. The blueprints inherit from a C++ class. It's all C++ in the end. And C++ is a great way to write your program as well. So what do you code your game with? If you've got blueprints, you've got C++, and both of them are incredibly powerful. So let's talk about that a lot. Blueprints, they should be considered the default go-to. They are the bread and butter of your game. They can do basically anything C++ does. They can be, and importantly, when you're working in the editor here, you can make changes to blueprints and see the change happen in real time as you're editing them. I mean, there's a little bit of a caveat to that. I mean, if I edit a blueprint like this character blueprint, I might not, I wouldn't see it. It depends if you're editing defaults. But anyway, you can edit them and see what you're doing because with C++ you have to recompile, which is, you basically have to shut it down. That's not totally true. They've got like hot reload, but I never got hot reload to work that well. I don't even know if they even pretend to do that anymore. That's my own ignorance though, because I just didn't use it that much. I just shut the thing down and would run it again. So obviously that's a huge drawback for C++. It's a big reason to use blueprints. But like I said, blueprints, bread and butter. If you want to know how do I implement something, probably blueprint. Probably blueprint. And it even has its own debugger. So, you know, it's not like as powerful as C++'s or whatever, but it can be even more powerful in some situations because you can click individual entities and see their blueprints and stuff in the level, whereas, you know, C++ debugger is going to be detached from the editor in that sense. You wouldn't be able to click something in a 3D world and have it, you know, focus its debugging on that entity. It wouldn't work that way. So definitely excellent. And in fact, sometimes you are forced to use blueprints. There's actually a lot of situations where you're forced to use blueprints, and I say forced, but technically there's kind of a way to eke by without blueprints and kind of implement things in C++, but it is nasty. So much of the animation system, for example, very poorly exposed in C++. You can do something very simple like play an animation, but you really can't have like a state machine and stuff like that, which is with the blendings and the interpolations and stuff. That is best handled through blueprints. AI behavior trees and blackboards, an absolutely other really important use well, a necessary use of blueprints. Some of the stuff you can talk about in C++, but it's just really, really much more difficult. So you're going out of your way and you're losing what the greatest value of, like I said, what an engine is. An engine is a series of tools to help you edit your game, like a map editor, an animation editor, the retargeting system, the state machines of animation, the state machines of AI, which was called behavior trees. Blackboards, which is your AI's memory. These kind of things are really, really nice tools to have, and it makes it really nice to edit them inside of the editor. So even if you could do this easily in C++, you wouldn't want to, because you'd lose a lot of the value of the editor. And it's similarly, if you've got sequencer assets, and cutscenes is an obvious one. UI is surprising. So there's a couple ways to do UI in Unreal Engine. There's I think it's called UMG, which is essentially their C++ UI. Widgets essentially build on top of UMG, add new functionality and features. Think of it, if since probably a lot of you are developers, I would think of it kind of like the difference between Win32 and C#, like MEF or something, or yeah, just any modern UI framework built on top of C++ with like a XAML structure. It builds on top of UMG, so you could kind of reinvent the wheel from UMG. But widgets are really, really nice, and they have a lot of things. They have a lot of features like animation and such. And again, even if you could build UI in C++, that's not my preferred way to do it. I know some people. I mean, we have to do it for our product for some of UI, but it's not ideal. Not something we've done in a long time, really. You don't write hard code. So there's a good reason to use blueprints. You know, you really want to use blueprints because it's just got all these benefits, and sometimes it's necessary. But of course, blueprints have drawbacks. And one of the main penalties people point out, if you go online and you say, why would anyone ever use C++ in Unreal Engine? Well, a lot of people are just going to say performance. And yeah, it's true. Unreal Engine, I think it was later in the 4 years, 4.x, they were experimenting with having blueprints compiled to C++. Seemed like a really cool idea, but that idea got dropped. Instead, well, how blueprints work generally is it works a lot like C#. It's compiled into a bytecode that's fed into essentially a blueprint virtual machine during runtime, and they've actually done a lot of work between 4 and 5 to make sure that's as snappy as you can possibly make it. So I really don't think performance is a good reason to just write blueprints. And for the most part, if your logic is well designed, It's not going to have like huge performance bottlenecks. It's really easy to write bad code though. I mean, don't get me wrong, but C++ won't save you from bad code, right? It just won't. So performance, everyone says performance. I don't think performance is the real problem here. I think it's the fact that you have an incredible amount of difficulty dealing with complex logic. As you add complexity to blueprints, this just explodes. It's not like, it's like a nonlinear effect. The more logic you add, it's not twice as worse, it's like squared worse. And even very little logic can quickly get into this kind of trouble. This is obviously pretty cherry picked, holy heck. But this is just how code looks like when you're just making your game, you're just slapping things together. And if you don't design some intricate architecture, which takes hours and hours and hours, just to line everything up and all that, and try and tame this wires, you lose the point of speed, you know. So blueprints ultimately, and if you have to edit your code, or how do you edit this, right? Even let's say you design this as some perfectly beautiful two-dimensional image with, you know, the lines all going in a nice way. Now you have to edit it. Well, you have to do that all over again, right? So all of your beautiful structure is gone now, and you have to redo it again. So not only are you adding the nodes, but now you're kind of making some kind of two-dimensional architecture so that you can read it at all. And none of that exists in C++. And so, yeah, like I said, it's handpicked what I was showing. The mess could be tamed. This is bad. You should really not end up with this. The blueprints have a lot of encapsulation features like functions and, you know, and inheritance and all that stuff. A lot of the same kind of stuff you rely on in C++ to encapsulate. But it just takes more time when you're dealing with a large amount of code. It actually will take a lot of time. It's difficult to read because the density is extremely low. You know, for example, if we take a look at just some blueprint here, you look at this by reading left to right. You know, you're like, oh, okay, I can read this, and you're like reading like this is like one line of C++. Like right here, this is all like one line, and this is like another couple lines. You know what I mean? You have to like scroll, and you can kind of move it around and stuff like that. But it's just very the opposite of dense. It's super duper sparse. So reading it is slow, editing it is slow, but for small amounts of code like this, it's beautiful, and it's very, very editable. So what's the interplay here? And I think that's an important thing to talk about. So all right, so this is my hot take, right? The drawback is that blueprints waste your time. And this is the same reason that we don't have programming languages that work like this generally out in the world. I mean, yeah, there are a few, but you just don't take something like this too seriously, because ultimately you're going to hit this problem. And ultimately you need a lot of logic and complexity when you're doing basic things. So this kind of thing should be taken seriously. I would take this way more seriously than the performance drawback. I would take the fact that it wastes your time more seriously than the performance issues. Yeah, very, very sparse, very low information density, very slow to read. Not ideal. Not ideal for anything with even modest complexity. Enter C++. Look at this. Look at the density. Oh my goodness. So much code is happening so quickly. Super dense, super readable, easy to modify. I don't have to draw lines between. So, you know, blueprints, every single one of these is like, well, it's like I draw a line between each of these. I have to draw lines, you know. This is implied, just the fact that it goes up and down. Very easy to modify. There's lots of powerful tools available, you know, like refactoring and navigation, and we'll talk a little bit about how Visual Assist aids that. But this really is why you use C++. It's not just performance, it's just so much more powerful way of tackling complex logic that won't get you spun up into, you know, trying to lay out your little two-dimensional towers. Because that is a huge time waster. At least it was for me when I'm playing with this stuff. So enter C++, it resolves that issue with blueprints. You even get a performance boost. So a lot of people would say, like I said, performance is the main reason. I say everything else is the main reason. Incredibly powerful debugging. And for example, Another way that debugging is powerful in Blueprints, like, well, I mean, in C++, Blueprints, it's really nice because you can have this kind of sense of, I can click this dude and I can lose my mouse. Yeah, so like, here's one guy, and I could actually look at his, I could debug kind of what's going on in his blueprints, right? In the C++, that's a little harder, but C++ does allow you, but let's say that there's something going on or you don't understand something in the base class of your blueprint. Well, you're essentially done at that point. C++ debugging, you basically can get the entire engine source along with, you have to download it separately, the symbols for the engine, but you get all that. So if you're the kind of person who, and when you come across these like hard problems, like I definitely have come across a few bugs in implementation and stuff like that, and issues that I couldn't understand why is this, I registered this and it's not showing up on the map. Well, you can actually look at what the engine's doing with your call and say, oh, so at some point it's failing, and here's where it's failing, and this is why. You can't really do that with blueprints. So it helps dig you out of some pretty nasty holes too. But of course, C++ has some pretty major drawbacks. If anyone who's probably learned the language, it's pretty daunting to learn. It's a hard language. They've added a ton of stuff to it. It's a mixture of very legacy ideas and modern ideas all slapped together and interspersed. You can use C++. You could use very C-like ideas, or you go all the way to C++, 17, 20, whatever, and have very highly encapsulated ideas. So it's difficult. So I'm just going to, so my argument is going to assume, I don't think this is a good argument to learn C++, but I'm just going to assume this isn't your first rodeo with C++, because then I think my points are a little bit more pointful. Another problem with C++ is you have a lot of boilerplate. So that's where the slowness of C++ comes in. When people say it's slow to write something in C++, that's what they mean. Like it's just an example. Let's say I wanted to add a new class. Well, I have to create a new file. I have to lay out the standard includes, standard class stuff. You have to inherit from base classes, make sure your constructor calls the object initializer and overrides the parent. All this stuff has to happen just for you to start writing code. There's ways around this too. You can improve because templates and stuff like that, like for example, Visual Assist feature can aid this, but there are definitely drawbacks. And here's one that's if you're just totally new and you're thinking, well, I'm going to come into this and I already know C++. I know C++ 20. I know everything there is to know about a std vector and all that. Well, guess what? You're not going to use any of that. You don't get any of that because Unreal Engine 5 uses its own STL. So all of the familiar tools that you had, you can't use any of them. I mean, I guess you could, but generally it's best to stick with their structures because they memory manage them and stuff in a particular way. And they also have a lot of non-standard extensions that are going to confuse you. You're going to have to learn about like, for example, U functions, U class, U macros, all that kind of stuff. They're splatted all over the place and are completely necessary for you to actually write the C++ code. And Visual Studio honestly struggles. So my own interpretation is I really believe strongly that Visual Studio is the strongest platform to code in Windows C++. It's just got so many industrial level features that sooner that you can just not know about until you need them. You know what I mean? Particularly with debugging and stuff like that, you just have so much power behind the system. There's a reason it takes a while to start up. But it does struggle with the non-standard extensions to C++ because the way Unreal Engine works is it has its own essentially compiler. What it generates for Visual Studio, the project and solution, it's just for editing. It's not really building the solution when you build it. It's running like the build system and grabbing all your code and combining it into monolith files and stuff like that. And it's not actually using Visual Studio. It's not. So they don't have to make the Visual Studio projects really that sensible or grokkable to Visual Studio. That's one issue. It could be totally messed up. You know, project file and solution, all the includes can be messed up, everything can be messed up, and it doesn't matter because it's not being used to compile. So that's one source of messiness. Another source of messiness is the fact that is these non-standard extensions like U functions, because that stuff gets defined here in this generated file. And generated files only exist once you compile. So when you're adding new code and whatnot, it's going to have, I just made sure to compile this because I just was tired of looking at all the problems that this had. So compiling, making sure everything is clean, that really helps. But that's another drawback. It's another drawback. It's another difficulty in parsing because technically this isn't valid C++, right? This is totally nonsense when interpreted just in a straightforward way. So that's a problem. And that results in failure to navigate and refactor commonly occur. It really is a problem that I've had frequently myself in my own personal experience. Quite often, if you're just doing a lot of renames and moving stuff around, Visual Studio just gets lost and is just unable to keep up. I don't know exactly what's going on, and I'm sure that they'll improve on that because that's a rather strange thing to have, but it is something that I have absolutely noticed. And of course, red squiggles and stuff like that are very, very common. Even like when code is going to compile because it's just not standard C++. But we do have a solution to these issues, and it preserves the value of C++, and it is Visual Assist. We have a plugin for Visual Studio that does, think of it like IntelliSense on steroids, essentially. We actually have our own parser that we have maintained over the years, and that is an incredibly expensive and time-consuming thing to maintain. It's very difficult and complex. There aren't a lot of other people in the world that do this. And so that is what we use as the source of our power, because when we have our own parser, we, for example, can modify it to fully understand Unreal Engine syntax, which is what we've done. And it also can allow us to be faster. Our parser doesn't have to be, like, for example, the parser that Visual Studio uses to understand this code is essentially a compiler front end. It's very well in depth. It's like Clang, right? It's very in depth, very powerful, but it gets tripped up super easy, especially when you're dealing with nonsense like this. So our parser is the source of our power, really is, and we have a huge variety of navigation and refactoring features, as well as a bunch of other features. And I'll show you one of the cool ones in just a bit, which is code inspections, which I really, really like. And we'll do a little quick demo. Another besides just being able to understand Unreal Engine better, we're actually really, really fast. Like I said, because our parser doesn't have to be written as a front end, it can be written as an editor parser that can be really, really super, super fast, and it can understand your code, and it can skip over issues. It can be like, oh, that's problem code. We don't need to. We can just forget about that line and keep parsing instead of just breaking. Right, that's really important, especially when you're in the middle of the flow. So we try to always work, and we do it very, 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 very fast, like finding symbols and stuff like that. All of the code of Visual Assist that does all this heavy lifting is all C++. The only thing that's the only thing that's Win32 are a few interfaces to Visual Studio and the UI, right? So that is a real benefit. We don't have a lot of, like I said, it's essentially a superset of IntelliSense. So a lot of developers that use us, and we're very popular in the Unreal Engine space, just turn off IntelliSense because it saves them performance. It saves them from having to have like red squiggles. It saves them from a lot of the issues that they would otherwise encounter. Oh, you know what? Actually, I want to go back and add one thing. So a benefit of C++, I don't know why I didn't add this. One other benefit of C++ that you get over, so yeah, it's really complex and all that, but AI, right? I mean, I didn't even mention that. So like if you're like, oh, how do I implement this? AI can literally hand you code for a lot of this stuff. Even if you don't know that much C++ or don't know that much Unreal Engine C++, AI's got your back. And in a way that it just can't with blueprints, right? You actually do have to be an expert in blueprints. You don't have to be an expert in this to get started, at least, right? You really don't. And AI can explain a lot of this stuff. It does a really good job of it. Anyway, right. So Visual Assist, a lot of specific tooling. I don't know why these pictures, well, actually, they're probably not blurry for you. Are we have a lot of specific support for Unreal Engine. You know, like the U function macros will provide suggestions. We're smart enough to try and I guess some. I'll give you specific examples. Let's see. Like server, netcast unreliable, like a multicast and with validation, stuff like that. Things where there's thunks will understand where, so for example, if I have some server method like with validation, and for example, you would have like, if I had pickup and it was server method with validation, you would have pickup underscore implementation and pickup underscore validate, right? And if you renamed pickup, you might not rename those methods. Or that's another place example Visual Studio will get confused. So they'll be like, your pickup method is undefined. But of course it is. Actually, it's just because you have to define it with underscore implementation, underscore validate. There's a lot of little things in Unreal Engine like that. And we have been lock pace with all of that. So we've done, I think we've done a great job with that. And it's why people use us. That the performance, the fact that it works, even in gigantic code, all that are reasons people have used this plugin and continue to use this plugin for development in Unreal Engine specifically. And of course, it's just great for general coding. You know, you might not need lightning fast performance in, you know, a small little, you know, test app or whatever, but it still helps. Everything faster. Another thing is our UI is very minimal, stays out of your way, and it's very easy to use. But access through keyboard shortcuts is the best way to access our UI. But of course, we also offer it through menu options, click screens, and all that. So we try to be super snappy, super easy to use. The UI is very simple and straightforward, and it's powerful. It's got a lot of power and features that you wouldn't find anywhere else inside of Visual Studio. So it's good just for general tooling. And I'll show you a little bit about code inspections, one of my favorite features that actually can rewrite code for you to improve it. Not in an AI way, although maybe AI is coming in the near future. It's not a way that, not like AI, it's very rules-based, but it can modernize code and find issues with your code and whatnot. And we'll talk a little bit about that. All right, so let me go into a demo. I want to talk about blueprint concepts and praxis. So what do you actually do? I talked about why blueprints are good, why C++ is good, but the way that you actually do this is you take both. You just take both. For every class, let's go through this. All right, so this is going to be a little bit more complex, but because this is, you know, this is a big project, right? It's not like a demo. It is a demo, but it's not a great for a simplified demo. So there's going to be a little bit of ropes. So if we look at this character, that is an instantiation of this blueprint. This blueprint inherits, if we go to class settings, inherits from BHero default. All right, jump to that blueprint, class settings, character default. Okay, class settings, Lyra character. Now we're inheriting from C++. So C++ feeds up into blueprints very elegantly. So you inherit from C++ with your blueprints, and then you can basically you can define your defaults and all that stuff in here, and you can set your defaults in blueprints. A really common one is, for example, if I have a character, you know, I define my custom character here, and you know, it has a model, it has mesh and stuff like that, but you don't actually set the mesh here. You can set the mesh here. You can add a resource inside of the editor, and you can get a reference to it and code it into here, but you lose a lot of the value of blueprints here. So blueprints are great for visuals. So what you would do is you implement, you know, this is what's been done here. A modular character is literally just a character. So they've essentially done this here. This is a really good example. That, like I said, it's a little bit extra complex to make it, which obfuscates the point a bit. But you should define all of your base classes in C++. all of your blueprints should inherit from something that you have, some your class, even if it's really thin like this. Look, modular character is super thin, right? It doesn't even matter. It can just be your character. It can have no code at all. My class, you know, if your game is called Lyra, then a Lyra character can just be nothing. And that's fine, because that gives you a blank space that you can fill in later. And then you inherit that from blueprint. And then you can, you know, inherit your blueprint a few times. But the whole point is this gives you a place to put C++. So later on, if you're like, oh, I'm wired up to the gills, I need to collapse some of this logic, you can implement it in C++ and expose it to the blueprint. I can just do it right here, and then all of a sudden, I have access to it. I can just type the thing in and it'll appear. It's that powerful. But what's more difficult is going from blueprints to C++. So these C++ classes are going to be inheriting from blueprint classes, and they really shouldn't be referring or talking to blueprint classes too much. They absolutely can, but it's best to keep the flow bottom up. C++ flows into blueprints, and then blueprints flow into your game. So I think that is a really important, that is how I have done every single project that I've ever worked on in this. Like I said, starting even with a blank class and just inheriting from that, so that you have your own custom C++ that you could edit later, even if you don't use it at all right now. And I think that is a really, really powerful technique that gives you literally the best of both worlds. And you still have, like, you still have this, you know, visual system and, you know, this ability to edit. You can customize things and all these defaults and stuff. It still gives you all that capacity and the capacity to edit instances and all that. So it's a really beautiful way to do things. I think it is the way to do things. I don't think there really is a strong argument for doing things any other way. Like for example, I don't think you can write a game entirely in C++, and I don't think you, unless it's a very simple game without any kind of networking or anything, you can't write a game with just blueprints. This is how it's done. Base classes in C++, inherited by blueprints, and from there you can inherit blueprints with other blueprints if you want. You can start building your hierarchy, and then that's what gets into your level. Now, sometimes you have to, like, let's say you have spawner logic. I guess I could really get into the weeds here of the technicals of how to do it and kind of the, well, sometimes you might have to refer to blueprints. So, you know, you can have a pointer in here that you need to fill in with a blueprint. It's blank in C++, like a spawner. If I had a spawner and I wrote the logic for the spawner in C++, the spawner needs something to spawn. It's not hard to do. You can still refer to that very easily. But you don't want to do too much of that backwards reference, because it becomes a little bit trickier, because then you know, kind of looping around, and it's less clean of the bottom up approach that I really do recommend here. And we'll show a little bit about navigation. I was showing it before, but it's just super duper fast to do anything like find references, to navigate, to do. I personally love go to related, for example, because I can go to Lyra character and I say, what is Lyra character? What is modular character? I don't have to just navigate to modular character, navigate to pawn. I can instead say, oh, well, Lyra character, here's the entire base class hierarchy. It's really powerful way to kind of explore code, derived classes and stuff like that. And, you know, you can go pretty crazy. Like, there's probably a lot of derived classes from character here. It's just a powerful way to navigate. Also, for example, let's say, like, you know, you're jumping to your code, you can say, oh, and there's powerful filters. It's very, you know, it's just such a powerful methodology for navigating and refactoring and looking through your code. Like, for example, if I want to open a file, I can search through all the files very insanely quickly, like Lyra. I don't have to, you know, like the Visual Studio version, it's like typing in here. If I type Lyra character, well, let's see what happens. So there. It's slower. It's not his feedback. It doesn't have filters. Like, for example, we have filters here. Let's see, display edit control for persistent filter. You can filter out, like, say, I only want to see headers for some reason, or I don't want to see cheat. You can filter out cheat. It's just such a powerful, quick, and reactive system that gets you around your code quickly. And of course, we have the same thing for symbols. We have the same thing. We have the same kind of UI simplicity all throughout the product. And so we're able to do things very quickly. keep it very simple, you know, like just even something as simple as a list of methods that you can jump to within the file. When you have files this big, or even 600 lines, is essentially indispensable. You know, that's kind of a small file. It's just such an easy way to quickly say, okay. A lot of times in C++, you'll have to look at the, you kind of navigate to the header to kind of see all the things that are defined, and then jump from there using goto, for example. But you don't have to do that. You could just look at this, and this is even more dense, and it's searchable. You know, it's negative filterable. So just a lot of little things like that, and we have all kinds of powerful features for, you know, renaming and navigating and finding references and everything you would expect from IntelliSense plus more. And I'll show you one of the plus mores here in just a bit. So we'll talk about that right now. Okay, let me see if I can open code inspections, because I want to move to something that's a little bit purpose-built for this. All right, I move this. There we go. And we will turn this on. All right, so code inspections, I was saying before, is just a really powerful way to look at code that could be improved. Because like I said, C++ is a tremendous mishmash of old and new. And there are so many different ways, like in almost any programming language, to write the same thing. Well, this is maybe the best way. I mean, we want it to be the best way. I think it is the best way to modernize code. And what it'll do, not just modernize code, but we'll just focus on that feature, because that's one of the many features. And we'll be introducing new, very important ways to use this in the next release. But for example, if we've got this shared pointer constructor, well, this really should be make shared. Bam, done. Another example is this is not used. We can detect that. Pretty nice. This, well, that should be a raw string, right? Bang. And you can actually do that from here. I can select large groups of things. Let's see, I'm just going to select everything. I can apply it, and bam, everything in the file has been improved. Now I might need to do it twice to kill everything, because, you know, when you correct things, it might find new things with the new corrected code that you can further simplify. But that's code inspections. I absolutely love this feature. It is so powerful, especially as you're editing code, just to kind of understand. Like, here's the old trick. If you're an old hand in C++, you've probably done this quite a few times to limit the memory of a vector. Well, yay! Now we have proper erase. Simple things like in placing, so it can improve performance. It can fix issues. It's really powerful. We have gone through and we've made sure that every single one of these is something you're going to want to do. That's something that's interesting, in the sense that you're like, oh, it's not something you're going to ignore. It's not noise. This is every single time you're going to want to be like, okay, yeah, you're right. You know what I mean? That's the point. And it works as you're writing. As you're writing the code, you'll see a blue underline. You'll be like, oh. Although you probably wouldn't do that. No. But this is such a powerful feature, and it's a feature that we keep coming back to and wanting to do more and more with. So I wanted to show it off because I personally love it. Anyway, that's my rant about random stuff in Unreal Engine and Visual Assist. I think that specifically I really wanted to get across, and I really wanted to talk about what the value of blueprints versus C++ are, because I think that a lot of the information out there is wrong. I think a lot of people think that C++ is there for performance, and you don't really need it if you're not that worried about performance, or blueprints are fast enough. I agree, blueprints are fast enough for 99% of things, but that's not why. That is not why you use C++. This is why. Because C++ is a powerful method of organizing and writing code. It's something that's been developed over many years. It's stood the test of time for a reason. And there's also a reason why we don't use this to actually write code. And we probably never will, because of this. low density and all that. So I think that is, if you take one thing away, it's the answer to C++. Why C++ is because blueprints don't do a good job as complexity increases. They waste your time. And I think that is all I have to say. And hopefully we have some interesting questions. If not, that's fine too. But I had fun talking about it. So Nuno, if you'd like to take Q&A.
Yeah, sure. Thank you, Chris. Just one thing is, I also love code inspections. I think it's a great feature. So thank you for showing that to the audience.
Yeah, I
And
couldn't
I
miss
think
that. Yeah, I had to show that.
I think we got a few questions. One is, are blueprints hard to learn if you already know C++?
Oh
I think
yeah. I mean, it's
already answered, but let's go over them again.
yeah, I think that's true. It really is, because with C++, you're kind of used to knowing what you have access to. So for example, blueprints is essentially, I've got just all this global stuff that I can kind of pull in, you know what I mean? And it's a searchable list, but like but it's hard to know like what to use and when, and there is definitely complexity here. And what things are titled here and what things get exposed as to blueprints can be a little different than C++. So it definitely, it's not, I want to say blueprints are simpler. They look cute. Are they really simpler? I don't know. Assuming you know C++, I don't know how much simpler this is. Now, you can't get away from blueprints, so you're going to have to learn this anyway. Like I said, you can't get away from either blueprints or C++. You're going to have to make your bed with both of them. But is it easy? Not really. And you have to do stuff like this. Look, the whole point, some developer literally went here and right-clicked and like added this little control point so that the line would go up, line up right. You know what I mean? That kind of, it's all super duper time consuming. And I'm just going back to my point again, but yeah, it's hard to, it takes some time to learn, even to do basic stuff. Like now the AND system is like a little pin thing that you use. So it does take a little time, and you don't have AI as powerfully to access this because AI can't imbibe this. The best it can do is imbibe the documentation, which is not the same as imbibing the code, which is what it does for C++. So you're more on your own.
All right. Other question we got is, can I mix C++ STL with Unreal Engine 5 STL, or do I want to do it?
Yeah, I wouldn't mix it with their STL, but you can use STL. And yeah, so the answer is essentially yes. You can.
Okay.
But like I said, there's a reason that you shouldn't. I guess, so think of, like, for example, in STL for vector, you can assign a memory allocator, right? You could override the default memory allocator because you're a game engine, you're kind of trying to be as smart and efficient as you can with your memory allocations. So that's one thing that they almost certainly do for their like T array and stuff like that. So you'll lose out on a lot. You could actually lose performance, and your memory will be less managed potentially if you use that too much. So I would honestly avoid it. You can do that, but I would minimize it. And for another example of where you can't is if I go back to Lyra, I don't know how much time we have. I'm wasting time, but go away. If we're storing pointers and stuff like that, are we storing any pointers? Yeah, here we are. You can't use STL because these things, these properties and stuff like that, and let's say I have an array of these pointers. The Unreal Engine memory management system is not going to understand what's going on when you add things to a std vector. You're going to confuse it. So you really should, there are definitely some restrictions where you absolutely can't as well. You could mix the two.
Okay, I guess we have some beginners because we have one question that is, if you were to start today doing Unreal Engine dev, where would you start so it doesn't be overwhelming?
You just have to get used to being overwhelmed. I don't know. How do you, I mean, you start by thinking this is super duper fun, so that you don't ever get that feeling of overwhelmed, right? Because what, like I said, Unreal. Back to that Notch quote about you need to write your own game engine. A game engine is not a renderer. A game engine is all this, all this editing stuff, all this 3D stuff, the map editor. That's the game engine. That's the stuff that takes a little while to learn, but it's really fun to learn. Like learning virtual effects with Niagara is just super duper fun, even though, yeah, it's actually there's a lot you can learn. So it's compartmentalized, so you don't have to learn everything. You can wait to learn the AI systems till you need your AI to be complex. You can wait to learn animation retargeting until you need to animation retarget. But I don't think there's any answer to how can I learn Unreal Engine without feeling like there's a lot out there, right? It's just there is. But but one way to reframe it. So a lot of Unity people are scared of Unreal Engine because of all these things that they have to learn. And sometimes as developers, we make the mistake of reading code is sometimes harder than just rewriting it all from scratch, right? Learning to use someone else's implementation and the quirks and stuff of that is sometimes easier to think, I'm just going to re-implement it from scratch. But this is so worth learning this over writing your own, because you're not going to write your own animation retargeter. You'd be wasting your time, stuff like that. So learning this stuff is just, it's worth it, even if it feels overwhelming. Sorry, yeah, that's my answer.
Okay. Yes, we have the next question that I think you already touched it a lot, but I think it's worth asking again. That is, and it's related with this. How do you usually search through Unreal Engine's massive code base? Any tips?
Yeah, so absolutely. Like I said, the way I navigate around it is just a bread and butter type thing, is this open find in files. So if you know the file you're going for, bam, if you know the symbol you're going for, you can open the equivalent window for symbols. Navigation, I usually use this display methods, so I can hop to exactly where I need to go, and then, go to the implementation or declaration, or if I need to see a base class. So for example, these are all, so one design pattern that you use a lot is you almost always inherit from a base class in Unreal Engine, because that's the whole point of the engine, is it gives you bases. And you can see, what is begin play calling? So for example, if I have begin play, you always need to have this super. But what is super? Well, you can look at your base symbols and you can say, okay, what is begin play really doing before it gets to my code? Well, here's all the stuff that it's doing. It's calling actor begin play, which is calling pawn begin play, which is calling character begin play, which is calling modular character begin play. And you can hop through. I think this might be pure virtual. No, I don't think it is. But anyway, so you can go through all these begin plays and see what they do. And it's just such a powerful way to navigate your code and to find things out. And I think very quickly, if you learn one thing from this, as far as Visual Assist, let's say you've never used Visual Assist before and you're interested in trying it, despite the fact that I didn't really give the best explanation of it. I did this a little quickly, but the idea is Shift-Alt-Q is context-based commands. You can right-click and you can look at quick actions and refactor. We have all kinds of stuff listed there, but that's big. Context, Shift-Alt-Q, super powerful. You can get it's going to be a different pop-up essentially depending on what you Shift-Alt-Q on. So you can get quite a bit of that's all your mileage really. Now for refactoring commands, that you tend to need to use the there's not this, for some refactoring commands they appear here, but not all of them. I mean actually navigation commands, but yeah, so anyway, not all commands are accessible through Shift-Alt-Q, but quite a lot of them are, and that is an incredibly good way to get started.
All right. We have just a couple more questions. If C++ is better to tackle complexity, where would you use blueprints?
So you need to use blueprints because when you come in, because at some point your code needs to come into your game. So if I have this base class And let's say I had a base class person, like this Lyra character. Well, now you need to set a lot of things for your character. You need to set like their model and stuff like that, and maybe you need to tweak the walk speed and stuff like that. So by inheriting with a blueprint and by spawning the blueprint and by editing the blueprint itself, I can set like which model am I going to be using, and I can see that they didn't do that. The way they did it is programmatic here, but I can see that and I can modify it. And let's say you're trying to tweak the walk speed for something, I don't have to, recompile and guess and come back. I can just tweak a number right here under defaults, which you can barely see, but it's down here. See all these settings and defaults and whatnot. And I love how it even tells you when you've changed something from the default. So if you actually change the default in C++, you'll see that this arrow appears in your blueprint. You can actually slap it back to the C++ value. They're so beautifully integrated. But you need both. You really need both in order to get the biggest value out of Unreal Engine. You should have C++ as a base class, and you should inherit with a blueprint. But everything should be blueprints. Everything, all the items and stuff that you place in the world should generally be blueprints.
All right. And we got our last question, that is, could you show how to use code inspections again? I'm trying it at the moment, but the result is empty. Just before you go over there, Chris, Emily, if you still have some doubts about it, feel free to email me at nuno.castro@automated.com or chris@automated.com, and we will jump on a call with you if necessary to help you get started with it. But Chris here will show you again.
Yeah, so if it's not enabled by default for you, that's the number one thing you should do. So go ahead and go to Extensions, Visual Assist X, go down to Code Inspection, and make sure this is enabled. That's probably the issue. Or you might get lucky and there's nothing that Code Inspections is detected. Remember, Code Inspections isn't meant to be noisy. It's not going to alert every time for everything, right? It's going to alert when there's something that really does require your attention. So it might be that you just write very nice code.
Perfect. I guess this is it. Thank you, Chris, for the presentation. Just to remind the audience, we will be shipping pretty soon the new release of Visual Assists. We will have some great features in there, so I recommend everyone to install it and give it a go. I think you will really appreciate the effort the team has put into the next release, as we are pretty excited about it. Once again, thank you, Chris, for this amazing presentation. I sure learned a lot, and I hope the audience have learned a lot too. Anything you need, feel free to email any of us. My email is nuno.castro@holtomato.com. Chris is chris@holtomato.com. Feel free to email us if you have any questions or anything regarding Visual Assist. We will be more than glad to help you with anything related. And this is it for this webinar. I hope everyone enjoyed. Chris, any last words?
Thank you to all who attended. It was fun.
Perfect. Thank you, guys. See you next time.